Good evening. So I could see only one participant has joined so far. We can wait for a few more minutes before we start the session. We'll wait for 2 more minutes before we start the meeting to let others join if anyone wants. So we have already waited for 7 minutes here. I will allow anybody who wants to join further also, but let's not wait any further. Let's start the meeting. So as you guys might know that this is the live interactive session for the course Matrix Methods in Structural Engineering in NPTEL. So I am Sharanya Banerjee. I am a PMRF student, PMRF research scholar in the Department of Civil Engineering, IIT Delhi, and I am here to help you out with the problems that you are facing in this course, and I would like to introduce you to some earlier solved assignment problems from this course and some other problems as well. So without further ado, I will start the meeting. Good evening to all and greetings to whoever is watching through YouTube. The first thing that I want to do now is I will share my screen and I will give a brief introduction on myself, where I am coming from, where I am now. So just allow me a minute or so to share my screen. I hope my screen is visible to all. First thing that I would like to do here is I would like to introduce myself. So what better than my own web page that I have created. This is the web page where I have given details of what I am doing, how can you contact me and stuff. So you can take a note of this web page and you can try to contact me through this web page also. I am Sharanya Banerjee and I am a doctoral research scholar, Prime Minister's Research Fellow to be more precise, in the Department of Civil Engineering at IIT Delhi. My area of specialization is structural engineering, as you all might have already guessed. My research revolves around the various vibration control strategies for structures against multiple hazards like earthquakes and winds. So right now I am in Toyohashi City in Aichi Prefecture in Japan, where I am conducting research as a part of an exchange program between IIT Delhi and Toyohashi University of Technology, facilitated by Suzuki Foundation. So this is my contact information. You can find my institute email ID and my personal email ID here. You can email me in case you need any information about anything related to structural engineering, civil engineering and academics. This is my bio sketch, where currently I am doing my doctoral study under the supervision of Professor Vasant Matsagar and Professor Deepti Ranjan Sahu in IIT Delhi. In the Department of Civil Engineering, I have started my doctoral research from September 2020, and from April to October 2023, 6 months I am staying in Toyohashi City, where I am doing my research in Toyohashi University of Technology under the supervision of Professor Taiki Saito. Further, I have received some awards during my doctoral study, some being the Suzuki Foundation Fellowship, whereby I am currently in Japan due to that award, the Prime Minister's Research Fellowship, for which I am doing this online live session with you all, and some other awards as well. Further, I have 3 journal publications and 3 conference publications so far, and some others are currently under communication. My broad areas of research are, first of all, structural dynamics, vibration control devices such as seismic isolation devices, tuned mass dampers, multi-hazard engineering including earthquake engineering and wind engineering. So as you might notice that none of this is related to this course. However, these are my broad areas of research, and as always we always have to be very strong in the basics of our structural engineering, like the matrix methods in structural engineering, to study further about all these courses. So I'll stop my screen share for a moment now. Now I would like to just um, just speak to you about what are my expectations from these live sessions, and I would also like to know that from where are you coming, like what are you doing, from where are you joining this meeting, and what are your expectations from these courses, from this live session. So as the name suggests, this is called the live interactive session for the course of matrix methods in structural engineering. So the first and foremost thing in this course would be it will be very interactive. Here I will always be like coordinating the meetings, but I would like to get inputs from your side. I would give some problems and we'll solve it together. I expect that you have a notebook in front of you right now where you can just jot down the problem and try to solve it. I'll give you 1 or 2 minutes to solve the problem, and then we'll again solve it together for the whole class, so that you get an idea of where you will get stuck during solving the problem, and then you can ask, and then we can go ahead together. So as I can see that only 2 students have joined this meeting. I am not sure of how interesting this meeting will be on YouTube, because it will be kind of slow, because I would like to um, ensure that everybody together solves the problem and tries to understand the things from the basic level. So this will be my aim in this course, and I would like to now open the floor to first introduce yourselves and then also share what are you expecting from these live sessions. So can you one by one please introduce yourselves here? I'm still waiting for your response. I can see 2 students joining this meeting, Amit and Arpan. Can you kindly introduce yourselves one by one? Yes, yes, Amit.
Sir, my name is Amit Raj. Currently, I am pursuing BTech from NIT Patna, Bihar.
Okay.
NIT Patna, Bihar.
Yes, very nice. So, in which year are you currently studying?
Second year. Second year.
Second year, very nice. So,
Second
you
year.
have already completed your structure analysis 1 course?
Yes.
Okay, very good. And structure analysis 2 course is not yet conducted, I guess.
No, sir. No, sir.
Yes, but this is equivalent. This course in NPTEL is quite equivalent to the
Sir,
structure
sir,
analysis 2 course,
sir,
right?
I want to know that know that with the help of matrix with the help of matrix meta structure analysis can be analyze the real life structures or not. With the help of matrix meta structure analysis can be analyze real life structure or not.
Yeah, yeah.
I want to know that. I want to know that
Yes,
from
yes,
yourself.
yes. Very, very good question and very relevant question. So, as you have already taken the structure analysis 1 course, so you might be knowing that in the structure analysis 1 course, what you basically do is try to solve some beam problems and frame problems and
Trust,
very,
trust.
yeah, truss problems, very idealized scenarios, right?
Yes,
So
yes.
now what we
Yes,
are
ma'am.
actually trying to do in the structure analysis 2 or the matrix methods course is like we want to take this basic understanding into a level where we can actually solve any kind of structures. Okay,
real life
any kind of real life structures, yes,
like
sure.
bigger structures like Burj Khalifa
Yes,
or
yes.
some or
Any
somewhere.
structure, any like building like Burj Khalifa, any bridge like the Golden Gate Bridge of San Francisco, California. So the thing is, why like we always find it very amazing that how can this be designed by any like concepts like this, but the fundamental concepts remain the same. The fundamental concepts start from structure analysis 1. Now in structure analysis 2, what we will see slowly as the course progresses is we'll kind of relate all the different parameters of the structure, like the responses, like the velocities and displacements with I would rather limit myself to displacements here, because this is a static analysis course, so we will not talk about any dynamic effects like velocity and acceleration. So let's talk about only the displacements due to, say, dead loads, live loads, say wind loads. So what happens is we want to relate these displacements of the structure with the inherent properties of the structure, like the material, the dimensions of the columns, the dimensions of the beams, and we want to get a complete description of the structural behavior after a certain loading condition. So we want to create, actually, as you progress in this course, you will see that we have created various stiffness matrices. So what are these stiffness matrices? These stiffness matrices actually relate the nodal displacements at each node of the structure with the forces acting on the structure. So now if we have a very complicated structure, your stiffness matrix could be some of the for example, for a beam, a stiffness matrix would be a 4 cross 4 matrix, where you have two forces at the two ends and two moments at the two ends, and you want to find the displacement and rotation at the two ends. However, say if you want to analyze structure, say Burj Khalifa, then you will have a 4 lakh cross 4 lakh size of stiffness matrix. So obviously these concepts will be used to solve the real life problems, but the issue is, like, you cannot solve a 4 lakh cross 4 lakh matrix by your hand. So that is the reason we need certain softwares or certain
Like
computational methods.
software software name. Can you tell some software name which is helpful for
Yes, yes, sure.
software?
So
Can
I am absolutely sure that you will be taught some softwares like StatPro or SAP
हाँ हाँ sir
2000 or
हाँ हाँ
ETABS in
हाँ
your,
yes, sir.
yeah.
I have heard about this software like
Yes, yes,
जो
exactly. So,
that
these softwares are basically nothing, but these softwares are a computation based on whatever information you have feeded in the software. For example, if you have said that this is a building, big building with this much dimension of beams, columns, slabs, etc. So this software directly takes that building information, constructs the stiffness matrix for you, and computes the displacement at each node, and nothing else. This is the basic principle of these softwares. So if it is a very simple software, you can directly do it by your hand. I'm sorry, if it is a very simple structure, you can directly do it by your hand. And however,
yes.
as the dimension of the matrices go ahead, then it will be more and more difficult to do it by hand, so we use the softwares, but the basic fundamental concepts are the same as used in the matrix methods of in structural engineering.
Getting
Yeah.
sir. Thank you sir for the interaction
Yeah,
which
yeah, yeah. This is actually a completely interactive session. However, I am like uh, not very happy to see that many people have not joined. Right now, I can see that you are the only member who is joining this course. Anyways, but we can still go ahead. And so I have already known from what are you doing, and I also want to know, like, what are you expecting from this course? What are you expecting from this, especially this live session? Like, means what are your expectations from me? what should I do in these live sessions?
I want to I want to analyze real life real life problems like
Yes.
buildings building analysis like
Mm-hmm.
real life problems. I want to deal with real life problems.
Yes, yes, yes. That's very nice.
I want to deal
So,
with real life problems.
yeah, yeah, yeah.
Not
So,
not just bookish knowledge मतलब like book is numerical solving
yes,
problem. But I want to relate the knowledge with real life scenario,
yes,
real life problems.
yes, yes, yes. Very, very nice.
Are you
So,
are you getting my point? What I am trying to convey to you? What I am
yes,
trying to
yes.
convey to you? Are you getting?
Yes, yes, I am understanding that what you want to say is
Okay.
that in these courses you are always being taught like how to solve the beam problem, how to solve the frame problem, dust problem, but you cannot visualize that how it will help you to solve the real life problem, like
Real
a,
life problem.
a
Absolutely.
bridge in say Patna or a big
Absolutely.
building,
Absolutely.
right?
Absolutely.
Yes, yes, yes. That's very interesting. So, thank you for sharing your expectation with me. So, from now on, whenever I will be like discussing any problem, I will try to make the discussion as such that there is some practical implicability of that problem, right?
Okay.
So,
Okay.
it's not only just some
This
kind of beam or frame.
is what I want. I want from your side. This is what I want from your side. This is what I want from your side.
Yes, yes, sure, sure. I will try to do my best to provide this to you. And right now, since nobody else has joined, so you are my first and foremost priority now. So whatever problems I will discuss now, I will discuss it with the practicality on the back of my mind. Sure.
Okay. Thank you.
Okay, and so now I think for the timing you can mute yourself. I will just give some other ground rules on how this session will go on. And this is not only for this session but also for all the 8 sessions that will happen in this course. I would like to give some general, I think, points on how I would like to conduct this course in this live session. So first of all is every day I will first introduce myself, take the introduction of the all the new members. Today I have already got the introduction from Amit Raj, and I expect him to join all the further sessions also, so that we can together learn how to solve like the real life buildings or bridges problems
Okay,
throughout
sir.
this
Thank you.
live
Yes, sir.
session.
Yes, sir. Thank you. Yes,
Yeah,
sir.
and also whoever new will be joining in the further sessions, I would seek their inputs on what they are expecting from this course, and following which I would first open the floor for any doubts from the previous week's lecture videos. Like this is my first live session, so I would count this as the first live session after the first week's lectures. So I know that the second week lectures are already out, but I would like to limit this session to only the first week lectures, so that if there is anybody who is joining who has not yet seen the second week lectures, he doesn't feel that this is getting out of his scope. So we will have 8 live sessions and we have 8 weeks of lectures. So for each live session I would give more emphasis on the uh, corresponding week's lecture, and also any lectures before that, but not any lectures further ahead. So this is one point, and I would like to first ask for any doubts that you are facing in the lecture videos or understanding any concepts related to the lectures that are being conducted. Then once you have cleared your doubts, then we can move ahead with the solving of questions. To be more precise, these are actually the assignment problems from previous years. So any of your assignments that you are currently doing, they will be kind of similar to those assignment problems or based on the concepts already asked in the previous assignment problems. Apart from the assignment problems, I will also introduce some one or two problems from my side which I will feel that these are necessary for your better understanding of the complete course. So this is what my plan is for these live sessions, and without further ado, let's start the first session for this course. And I would like to now open the floor for any questions from the last week's lecture videos. So right now we only have Amit with us as a student who is attending this live session. So I would like to ask directly to Amit that do you have any doubts regarding the previous week's lecture videos, week one lecture videos?
Yes, sir. I have doubt
Yes.
regarding determinacy and indeterminacy little bit. Determinacy and indeterminacy.
Sure, sure, sure. Very nice.
Determinacy and
Yes.
indeterminacy.
Okay. And anything else?
Determination and apart from that, some problem in kinematic in determinacy.
Kinematic
Kinematic
indeterminacy. Yes, yes.
kinematic indeterminacy.
Yeah, yeah. Okay. So, do you have any very specific doubt, or you want like summary of the determinacy and indeterminacies of the structure?
Like summary.
Summary. Very nice. Very nice. So, with this, I'd like to then start today's session. First, just give me 1 minute to share my screen. I hope my screen is visible and my notepad is visible.
Yes,
Yeah,
yes.
yeah, thank you. So, yes. Um, so, just a disclaimer before I start, you have to bear with my handwriting for the 8 live sessions
No
because my
problem. No problem. No
handwriting
problems.
is not so
No
good,
problem.
and
No
that too
problem.
on the tablet, anyways. And so let's talk about the terms determinacy and indeterminacy. So yeah, since so now what do you understand by the term determinacy?
A structure which analyze by simple equilibrium equations.
No, that
A
is
structure
okay.
which can be analyzed.
That is correct. But I want to know that what you understand by the term in English language. Like in English language, what do you understand by the term determinacy?
Determinant which can be
Which can be
calculated.
determined, right?
Which can be determined or calculated, which can be determined
Yes,
or
exactly.
calculated.
Exactly. Yes, correct. So determinacy is in English language means object or a thing, a certain parameter which can be determined, right? So in terms of structure, uh, what is determinate and what is indeterminate? So in structure analysis, what are the parameters that we are interested to know in? Say there is a, for example, say this is a simply supported beam, right? And there are various loads on the simply supported beam, right? Okay, so before I mm, before I start explaining this beam problem, I would like to talk about this in a more practical sense of view. So So this is a two-dimensional view of something that I have tried to draw here. So can you tell Amit that what I have tried to draw here from this figure? To make things easier for you, let's extend this drawing. Now can you guess, Amit, what is the thing that I have tried to draw here?
Bridge.
This is a bridge structure, right?
Bridge.
Yeah. Any specific name of this bridge?
Arch bridge.
Arch bridge. Yeah. This is a arch bridge.
bridge.
Yeah. So how beautiful do you think arch bridges are? Very beautiful, right?
Yes.
Looks very good. And whenever we look at some arch bridge, usually the thing with arches is that they are from very ancient practices of civil engineering. So most of the arch bridges are usually very historical in nature. Nowadays very less arch bridges are made because there is a larger requirement of the material, right? Cable bridges are much more stronger than arch bridges, but arch bridges always have that historical aspect with them. That is why they are so beautiful looking. So say this is an arch bridge, right?
Yes, absolutely.
Yes. So now there is a very fine detail in the arch bridge which you will find if you like try to see very carefully, very closely, if you get to see any arch bridge properly. So you'd see at the end there are some rollers, right? You will not get to see this very often, but if you have a close look or have a very like objective look, that if you want to see the rollers, then you can see there are certain rollers in bridges at some ends. So one of the major reasons of this roller is that this bridge is directly exposed to the environment, right? So in the environment, temperatures are sometimes cool, sometimes hot. So there may be certain expansion and contraction at one end. So these rollers actually facilitate that extraction and contraction. Pardon me. The expansion and contraction of the bridge structure. So, for example, what do you think will happen if due to expansion and contraction? Why is it important to give these rollers for controlling the expansion and contraction of the bridges?
But I am not getting
Yeah,
what you're
yeah.
trying to say.
Okay. I'll just
Can you repeat?
yeah, I'll just repeat with a very simple example here.
Okay.
Say these are two kinds of system. This is first system, this is second system. Okay.
Okay.
So in the first system, this is completely fixed at both the ends. In the second
Yes.
system, this is fixed at one end and free to roll at the second end. This is a roller support.
Yes.
So now we expose these two beams, beams 1 and beams 2, to air, like temperature loads. Like sometimes we heat it, sometimes we cool it. We are doing it explicitly for these beams, but actually this is happening in a real life bridge. In the night time or in the winters it is getting cooled, in the daytimes, in the summers it is getting heated. So now what will be the difference between the performance of these two beams, beams 1 and beams 2? Which will perform better? What do you think?
Roller.
Roller.
In which roller is provided.
Yeah, but
Provided.
why is that?
because roller will allow deformation or movement in
Yeah, you're
horizontal
absolutely
direction.
correct. You're absolutely correct.
In
So,
horizontal direction. It
yes,
will
yes,
allow movement in horizontal direction. So
you're absolutely correct. Yes. So, if there is a plus T, say, for example, there is an increase in temperature, roller can expand like this. The beam can expand like this, and the roller facilitates that, right?
facilitate that
Yeah.
absolutely.
If there is decrease in the temperature, the beams contracts like this, and the roller facilitates that,
Okay.
right?
Yes. Yes. Yes.
So, so now what is the problem with this beam then?
Both ends are fixed.
Yeah,
So
both
it
ends
will
are
not
fixed. Yes,
facilitate the contraction and expansion. So crack may develop. So crack may develop or
exactly,
something else
exactly, absolutely correct.
or something else may happen in
Yes,
the
absolutely correct. Absolutely correct. So if we take just the free body diagram of this beam, or even this beam, both beams. So if it is exposed to say plus T, say increase in temperature, so there will be a
okay.
tendency of this to expand in the axial
Expand.
direction. Why the axial
Yes.
direction?
because because load is because thermal expansion will occur in axial in longitudinal direction
Yes, exactly, exactly.
along longitudinal direction
Yes,
longitudinal
exactly.
direction.
Exactly. So since this is a beam structure, this is a longitudinal member. If we heat it,
Longitudinal
it will expand in the axial direction. If this would be a plate, say planar member, so if we heat it, it will expand in both the directions, 2D directions.
yes
Similarly, if it is a cube, it will expand in three directions, right?
three direction three
Yes. So so now the beam is getting expanded in the longitudinal directions due to the plus T temperature change, but these fixed joints are actually resisting this, right? So
yes
when this is resisting this, now what happens is lot of stresses get developed in this region. Let me choose a other color. Lot of stresses get developed in this region, right? What is
okay
stress? I think we know what is stress. Stress means
yes
that if the
internal resisting force per unit area
per unit
internal
area,
resisting
yeah,
force per unit area.
exactly. So now if there are some forces being developed here due to the rise in temperature, there will be stress developing here, which will actually impact the axial resistance of the beam. So now the beam has to be made stronger to carry these extra loads, right?
Yes.
Which is not required in this case. Why it is not required? Because there is no horizontal force acting in this area. So there will be no stresses required in this area, and similarly the stresses here is also reduced because it is free to expand in one direction. Okay.
Yes.
So this is the reason this roller kind of supports are provided here. Well and good.
Okay.
Yeah.
Okay. Yes.
Yeah. So now coming back to our original discussion, that this is a real life, say, bridge structure, and now let me just increase the number of pages. Yeah. So so now I am idealizing the bridge structure to this kind of structure. I would want to know whether you agree or not. This is the bridge structure that we are talking about. We are idealizing this to this structure. Do you agree?
Yes.
Yes.
Idealized infrastructure.
Yes,
Yes.
yes, yes. So what is happening here is that since the bridge is what could be the dimensions of the bridge here? It could be say 30 meters in this side,
Yes.
and
Yes.
say 5 meters in this side. I am talking about a small bridge, say.
Yes.
right?
Okay. Okay. Okay.
So we can see that the aspect ratio of the bridge is very skewed, like it is very long in one direction. So when a object is long in one direction, how can we
Hmm.
idealize that object? We can idealize that object as a single kind of
Yes. Yes.
longitudinal member,
Yes. बिल्कुल.
right?
Absolutely.
Yes,
Absolutely.
yes,
Absolutely. Absolutely.
yes, yes. So now we are idealizing this as a longitudinal member, and here we are making this as a pinned support, and here we are making this as a roller support. This part is okay.
Okay.
Yeah. So now what kind of loads will be acting on the bridge? The first load would be the dead load of the bridge itself.
Dead load of the dead load, first load,
Yeah.
second live load and dynamic load
Yeah, yeah.
due to
Then
vehicle
various loads due to the vehicle. Say this
vehicle.
is a big truck vehicle
Okay.
which is moving on the roads. So this will have a very big load. Then a small vehicle, a small load. So there are various loads on the bridge, right?
Okay. Okay. Yes.
So now we have already understood that this is a idealized representation of a simply supported bridge structure where we have various loads acting on the structure. Now, as a designer, when you want to design the bridge, you have already idealized this in the point of view of structural analysis. But as a designer, what do you want to know about this bridge due to these loads, due to these specific loads, not due to any loads, due to these specific loads? What do you want to know about the bridge so that you can design the bridge?
What?
Yeah, I'll repeat my question. Like, I think you, okay. So, do you have you already completed the reinforced concrete design course or any steel design course in your curriculum?
No. No.
No,
No.
not yet,
No.
right? Yes, yes, yes.
Not at all. No.
Yes, yes. But I think in the current semester you will be having the reinforced concrete design course, right?
Next semester. Next semester.
Fifth or
Next
sixth?
semester.
Next semester.
Next semester.
Ah, okay.
Currently, I'm in fourth semester.
Oh, okay, okay, okay. So,
Currently, I am in fourth semester.
yes, sure, sure. Okay, no problem, no problem at all. So now, let's first understand the designer's perspective to designing structures, right? So right now, I think we only have the knowledge of how to analyze the structure and find some forces and moments and stuff. But
Okay.
why
In
are
shear
you?
force.
Yeah,
In
but
some shear force.
yes, yes, shear force and bending moment, right?
Yes.
Shear force
Shear
and
force and
bending
bending moment.
moment. But why are we interested in the shear force and bending moment? That is not yet clear to us. So let's just go to a little bit of basic to the design of structures. So now I have already idealized this structure as a uh, oh, so there is a message that my call ends in 15 minutes. So if the call ends by any chance, then I would request you to join again. I will join again to the same meeting link. Okay?
Okay.
Yeah.
Okay, sir. Sir, you are currently in Japan.
Yes, yes.
Currently, you are in Japan.
Yes, yes.
You are
Currently I'm in
currently in
Japan.
Japan.
Yes, yes, yes.
Oh,
Right now the time here is 10:15 in the evening, in the night.
evening, in
Yeah.
the night.
Yeah, yeah. So, anyways, coming back to our discussion, say, okay, I'll just draw this again. So I'll draw a bigger section of the beam, say. So this is a beam section, right? A rectangular beam section. Do you agree?
Yes.
Yes. So first, for structural analysis, we have idealized the longitudinal section to a single bar kind of element, right?
Yes.
But now for structural design, I want to again move one step backwards, and I want to know what are the dimensions of the beam, right? What are the dimensions of the beam? So what is its this length? What is its depth? Right?
Depth.
Yes. Depth
Depth.
of the beam and width of the beam. I want to know that. Now,
Yes.
why do I want to know that? So we were talking about calculating of shear forces and bending moments, right?
Yes.
Yes. So how does shear force act on the beam? Any like, do you want to comment on that? How does shear force act on the
Parallel,
beam?
parallel to cross section.
Parallel
Parallel
to
to
the
cross
cross
section.
section. Excellent. Yeah, yeah, yeah.
Parallel to cross section.
So say we cut. So say we only see this face of the beam, right? We only see this face of the beam here. Okay. So
Which face? Which face?
this front
Which
face,
face?
front face of the
Front,
beam.
front view.
Yes.
Front view. Front
Front
view.
view. Yes. So now
Okay.
what we see here is this is D.
Okay.
This is the depth of the beam D, right?
Yes.
So now we cut a section here. Okay. And the shear
Okay.
force in this beam acts like this,
Parallel to section.
parallel
Parallel
to
to
the
cross.
section. Yes.
Cross.
So what does that actually mean? Let's see this. What does that actually mean? So now that actually means that, say, this cut section is actually this cut section because there is a width to the beam.
Yes. Yes.
Yes.
Getting.
Yes. So now
I get it.
this section has a force acting on it like this from two sides.
Yes. Shear force.
Yes. So now how will I decide this width of the beam and this depth of the beam? Any idea?
How will you decide which and which?
Yeah. So say you are designing a structure. Say you are designing a let's start with a very simple beam. You are designing a very simple beam. This is a very simple beam, say only uniformly loaded, and then you want to design this beam. So how will you decide the depth of the beam or the width of the beam? How to decide that? So
By finding shear force acting in the beam and bending moment acting in the beam, then we can
ex-
design accordingly.
exactly,
We
exactly,
can we can
very
design accordingly.
exactly, very good, very good. Yes. So unless we know the shear force at this section of the beam, we don't know what will be the correct section for the beam. We don't know what will be the correct depth and what will be the correct like width of the beam. And why I am saying this is, say the shear force is, say, F, which we now know because of structure analysis course. Okay. The basic structure analysis course have like shown us how to calculate the shear force. Okay. So
Yes.
now if we have the shear force F, which will be equal to certain shear stress into certain area, and this area would be equals to B into D. So now if we know the shear stress, from how do we know the shear stress? The shear stress will depend on the material that you are using. If it is a plastic material, the shear stress would be something. If it is a concrete, the shear stress would be something else. So shear stress is directly depending on the material. So when you design a beam, you first decide the material, that I want to use steel or I want to use concrete here. So that material information already gives you the shear stress value. Now how will you decide the width and depth of the beam? Through this A. And how will you decide this A? Because of the shear force, right?
Yes.
Yes. So now I
Shear
hope you
stress.
can like little bit connect on why are we calculating the shear force of the beam.
Designing purpose. For the
For
designing purpose.
exactly, for the designing purpose. So now if we analyze very big structures, as you are interested in analyzing, as every engineer should be interested in analyzing very big structures. Say this is a very big kind of office building. Only I have selected the top part of the building. Okay. So
Okay.
this has many floors and many beams and many columns, this kind of frame structure. Now this structure is actually consists of this kind of beams at every point. At every point of the structure there are these kind of beams, and for
Yes.
each beam you have to actually calculate what should be its width, what should be its depth, right?
Yes.
So to
Yes.
know that, you actually have to calculate what is the shear force and bending moment at each and every node of the structure to design
Yes.
this structure. So this is
Yes.
why structure analysis one course is important, and to move from a simply supported beam to a say office building, the structure analysis two course is important on how you will make this computably possible. Okay, through the use of say different stiffness matrices, etc. Now
Okay.
coming to the bending moment, again the bending moment, why it is important is how does a bending moment act on a structure. So in this section the bending moment will act like this, something like this maybe. So now what happens is, this is the cross section I have taken down here. Okay, say this is the center of the cross section, we call this neutral axis, but maybe that you will learn in the structural design course in, and not now. So now I have taken down this black section here and drawn it with red. So now how the
Okay.
bending moment will act on this section, can you tell?
Bending moment is the result of bending stress developed in the beam. So,
Yes, yes,
bending stress is nothing but normal
exact,
stress.
exactly,
So
exactly. I'm,
in the top fiber
yes,
above the neutral axis,
yes,
tension will develop. The tension will develop in the bottom
yes,
below the neutral axis.
yes,
Compression will develop. So
yes,
this will form a couple,
yes,
and to resist them,
yes,
bending moment will develop
yes,
to
yes,
resist that couple,
yes, yes, exactly.
to resist that couple.
I am very happy to know that you have your basics covered very nicely. So this is exactly what happens in bending stress. So now a portion of your structure is actually a portion of the beam is actually in compression or tension, and the other portion is tension or compression. So how do you decide that what would be the depth of the beam or the width of the beam? By calculating the bending moment and then computing it with the bending stress, right? So this is
Okay.
how you design structures. Okay, so I am kind of diverting from your original question. We have not yet discussed on what is determinacy yet. Yes, but at any moment if you feel that I should come back to the topic and not discuss these things, you please tell me. There's no problem. Okay, you can be
No
as
problem.
free.
No problem at all. No problem at all.
Yeah, yeah.
You just carry on.
Yes, yes, yes.
You just carry on as your wish.
Yes, yes. As
You just carry on as your wish.
yes, yes, yes. Thank you, thank you. And always remember that this is your class. So whenever you have to tell something, you just speak up. You don't get shy or anything. So with this, we come back to our original discussion on what is determinacy and indeterminacy. But first, I think new member has joined this meeting, Kajal Gaikwad. So I would like for her to introduce herself to the audience, although the audience belongs to like only two persons, but still if you give an introduction I'll be very happy to hear. Miss Kajal, can you give a short introduction of where are you coming from, what are you doing?
Yes, sir.
Yes,
My
yes,
name is Gaikwad Kajal Bharat.
yeah,
My name is Gaikwad Kajal Bharat.
yes,
I am from Kopergaon. In college name in Sanjavani College.
okay, so very
Yes,
nice.
sir.
So right now what are you studying, like bachelor's degree?
Structural department, sir.
Okay,
Yes,
master's
sir.
degree.
No, sir. BTech, Bachelor of.
Bachelor in civil engineering.
Oh, yes, sir. Structural.
Okay, okay, very nice. So currently you are in which year of your study?
Structural engineering, sir.
Yes, like in which year of your study are you currently in?
Yes, sir.
Okay, no problem. Oh, no problem. So now, just one thing that I am asking with all the participants who are joining this meeting is like, what are you expecting from these live sessions? Can you please
Yes,
share
sir.
with us? Yeah. Like, what is your expectation? Like, what specifically do you want to learn from these live sessions? Because these are designed for your benefit. So if you give your inputs, I can modify these sessions in such a way that you will get benefited.
Okay, sir.
Mhm. So do you have any specific requirements? Like here, our friend Amit has already shared his ideas on civil engineering, structural engineering, and what he wants to learn from this course. He wants to learn how to actually design real life buildings or how to actually analyze real life buildings rather than only beams and frames. So what we have done in this course so far, you have joined a little bit late, is that we have considered a real life bridge structure, arch bridge structure, and now we are slowly getting into how it is determinate or indeterminate in nature, right? So do you have any specific requirements as such? If not, then I'll continue with my discussion, and you are free to stop me anytime if you have any doubt, and you can share your views. Okay.
Okay, sir.
Okay, yeah, thank you for joining. Now let's continue our discussion. Yeah. So
Okay,
this,
sir.
yeah, so this is a simply supported beam, which is actually idealized from the arch bridge type of structure. So now this simply supported beam, I would ask Amit, what do you think? Is this a determinate structure or a indeterminate structure?
This is this is determinate.
Yeah, this is this
I think
is this is actually a determinate structure,
this
and
this is determinate structure.
huh.
This is determinate
Yeah,
determinate structure.
yeah,
I
you are right. You are right. This is a determinate structure, but what makes it determinate? So how do we actually analyze structures? So now first, to understand whether it is determinate or not, first we have to think that what actually we are trying to determine from the structure, right? So first thing which we are trying to determine from the structure is the shear force and bending moment, say. Okay. So why are we trying to determine the shear force and bending moment? To design the structure, to actually build the structure on that river, right? To actually
yes
build the
to
bridge
design the
on that
structure.
river, we want to know the shear force and bending moment. So Unfortunately, the meeting got abruptly closed from Google Meet because 1 hour time duration was over. So again, a new meeting link has been updated in the group forum of the NPTEL course. However, I agree that it is difficult to immediately check that and rejoin this new meeting link. So I think we have to end the meeting here. So anyways, we would discuss from this point in the next class on what is determinacy and indeterminacy of structures, especially with emphasis on the practical aspects as well, not only just talking about beams and columns, etc. So I would end the recording of this meeting here itself, and I would post the 1 hour or 1 hour 5 minute video in YouTube for the reference of the other students. So that's all. It's it's already 7:50, so I am ending this meeting here, and I hope from the next day onwards this problem will be sorted, and maybe we can discuss a few more minutes from the next day onwards to um, counter for this loss of time. Thank you very much. I am ending this meeting now.